how we can implement this try and how we can efficiently retrieve the search. We can start by defining our try node, which will contain all of the words. So it could be, and in the constructor here, we will need two things. One is children's here, which will be our map A will point to a new try node. And the second thing which we will need is word, which will be a Boolean value, which will we'll have to have some way to know that this is the very end of our word. So here we will initialize every word as false. While adding a word, we can mark this Boolean as true to know that, okay, this is like a one word. So this word could be false initially. In our constructor call here, we will initialize our first try node. And as we discussed for word, let's define our node, which will be the current node. Now we will have to store every element in this format, character by character. So let's iterate through this word. So firstly, we will check if our node dot children already has this character new parent. With C, we will map it to new try node. And if this is not the case, we'll assign the character to this node and we will start appending to the children. And once we are done with this loop, we can mark the Boolean to true for us to know, okay, this is the end. This completes our add word function. Now let's write our search function. We will need essentially a recursive function. There could be two cases. One, if we have the dot character or we don't have the dot character. So for that, we will use this recursive function. Let's call it DFS, and that will take the current node and its index. And here, the very first thing, this is our base case. So if our I equal to word dot length, that means we have reached the maximum word length. So we can directly return this word length, and this will be the current character. Now the two cases, if our current character is dot, and there is the second case, which is if it's not. So let's complete the else case here. The very worst case, if our children doesn't have this character, then we can immediately return false. Otherwise, we will call this recursive function again with the next character. We'll get the child and increment our index. And this is what we can directly return as well. Yeah, now let's look at this dot case. So we will start iterating through each of the values of every children. If this is true, so basically we are going on each of these elements one by one and checking if this matches. And if this is the case, then we can immediately return true. But after all of these iterations, if this is not the case, then we can return false because we know that none of the element exists. And finally, let's call this DFS and we can directly return that also. So we can call this DFS by the root element with the very first index, which is 0. This completes our solution. Now let me submit this. It does work. I hope you found this video helpful. If yes, you can consider liking this video and subscribing to this channel. I post these videos daily. And thank you so much for watching.